Hi everyone, welcome to the lesson on Python file operations. So we will start with the topic reading and writing text files. So why do you need files? For any program, any NLP program or machine learning program, you need to read, write and persist the data. Okay, so you need to read data from the file, you need to write to the file, and then after you need to also able to ensure you can modify or append the file. So it's all algorithms needs data and this data comes from files. Okay, so you need to properly understand how the file operations works. So we will start with how to first we'll start with how to read a file. So read a file means it is read mode. So in read mode you can read the file. So and my file is under this path data example.txt. So if I go here, so this is my where my Python file is. So from here at this point, at this level, I have a directory called data. And inside directory, I have this example.txt. And the content inside this file is this. So be careful while giving the path, whether you are giving relative path or absolute path. So this is called relative path. Relative path means relative to the where my current file is. So from here, from where relative path means from relative to where my current file is. So if your file is not inside this folder, it is somewhere else in your system, then you need to mention the full path. Like, okay, that is called absolute path, full path, like C drive, program files, x86, or like the complete path you need to give if you want to open a file which is not relatively under where our Python file is. Okay. So please be careful with the path file and also be careful with the mode you are opening the file. So currently my intention is just I want to read the content what is there inside the file. So there is the file. This is the content. I just want to read the content. So for that you need to use this keyword, that string called R. And the way to open the file is called open. So file is equal to open path and then the mode and then you can content is equal to file dot read. Okay, so you're opening the file here and you're reading the content. And if you start printing the content, you should be able to see what is inside it. Okay. See, whatever content inside the file, I'm able to print it here. 42, hello world, 100, not a number. And one important thing is after reading is done, you need to definitely close the file. If you don't close the file, there will be a lot of issues. There will be resource leaks and there will be, you cannot modify file. It will be locked and you will be getting error, too many files open. Like that unnecessary errors will be coming. Okay, but one thing is you have to manually close the file. Okay. So let's see what happens if I did not close the file in case of exceptions. See, okay. So what I said is, okay, now I am putting my reading operation in and try exception block. So I am reading the same file here, but my file object is file2 now, which is a file object or file variable. So I read the content and then I am after reading the content, I am trying to convert whatever content inside that file into numerical data. Okay, so obviously you will not having this is hello world will not be converted to numerical data. So by default you will be getting some exception. Exception will be thrown and that is catched here. Okay, so that exception type is or error type is value error. It will tell okay, error converting to number. Okay, so now in this case what happens is here I have closed the file. Okay, now again I need to write here after this line file2 dot close. Okay, so it is not that straightforward. I mean straightforward in the sense, yeah, I have to close it, then it will be file will be closed automatically whenever exception is there. Okay, then let's run it. Yeah, error converting to number, obviously the file is closed. But the pain point here is every time you need to add this line file class. If there are like try exception blocks multiple times, 5 6 blocks are there, in everywhere you need to close. Okay, so it is good practice but it is bit tedious. Okay, so what happens now if you okay, now you keep remembering where that file is open. Now I am keep every time wherever that file is getting used, I need to ensure I need to use this file2 dot close. Suppose you forgot. Okay, so now what happens is, yes, the file resource is leaked and problem will come later and it will throw an error, too many files open and you cannot delete file, you cannot overwrite file. So if it is a log file used by the program, so it will you cannot access that log file. So always the best practice is whenever You open the file, ensure at all the required places you need to close the file. Just not at this place, at all the places, even here also you need to mention. So wherever that file operations is persist, you need to close this. But don't you think this is like kind of a lengthy process, not an easy way of programming, even though yes, the safety is good. See, the much more simpler way is, yes, you can open the file using with keyword. See, here you're directly opening the file. File2 is equal to like this in read mode. See, the new way of the more modern Pythonic way is this with open, and this is the path read mode as file. So here what happens is you don't need to explicitly mention file.close. It automatically closes. Okay, so this file.close, you don't need to call it here. It will automatically close. So that is the advantage of here. Same in case of exception, if there is a try catch exception block also, you have this. Whenever you are opening a file with this keyword with, Python automatically ensures whenever the operations on that file is done, it will close the file automatically. You don't need to worry when to close, when to open. Okay, so here this is my try catch block. So here I will get an error, and that after the error is thrown, I am not closing the file. It will come here in the exception block. It is telling error converting to number, but you don't need to worry of closing the file. Automatically it is taken care. Okay, so now if you just run this content, yeah, error converting to number, because I am reading there is a hello now hello in that text, you can't convert into numerical data. You see that, but the main advantage using this with keyword, as I mentioned, you can file closes automatically, works even if error occurs. No resource leak, cleaner, safe code, and much simpler. Okay, so we have seen why do we need file operations, how to open a file in read mode, and how important it is close to file, and what is the advantage of with keyword. You don't need to explicitly mention closing the file, it automatically is taken care. So that is the best practice. So now let's see what are the different approaches of reading the file. Yeah, this we have already seen. So with open as file content equal to file dot read, I'm just reading the file here, I'm printing it using this built-in function file dot read. So after opening the file, I'm using this function called file dot read. So all the data inside the file, it will be stored into this variable now content. Okay. Yep. So this is the content inside my file. Same file I'm opening, example.txt. So now there is a different way also to read the file, not different way, it's a bit slightly for lines perspective. See, if the file is too large and if it is too lengthy, so in that case you can tell with open as file. So you can tell, see, for line in file. So file is indirectly it contains a list of lines. Okay, so file means it will contain a list of lines, and with this Python syntax, automatically it will have all the list of lines. Okay, in the file object. So you can start reading with the line wise also. For line in file, print line by line. So instead of printing content at a time, here you can also mention line by line from line approach also. So if you start executing this, yep, you can see line. So I'm printing here line 42. This is much more efficient way. So like you can see how many lines are there, what is there in each line, 42, hello world, 100 number. So this strip we are using to remove any unnecessary escape special characters or white spaces. Okay. So there is also one more approach. This is also here we are using here. See here we are not using f dot file dot read. So file dot read here is used to read the content inside the file. But in this case, we are not using file dot read since you are already reading the lines automatically. So this file is a list of lines, and for line in each file, in this line already that particular line content is already there. Okay, so this is one more way. Okay, you don't need file dot read. So there is one more way where you can use file dot read lines. So here what we are doing is, yeah, again we are opening the file as file, and file dot read lines, it will read all the content as line. Okay, now again you need to iterate. All the content as lines means as a list. Okay, here you need to, again, if you want to see what is the content inside this lines, you need to iterate since this is a list. So like that you can also read the file. So it's just a way of way to use. But at the end, it's very straightforward. There is a file, you are opening in read mode, and you are reading the file. The first approach, use file.read, it reads all the content, and you are printing it. The second approach is you don't need any file.read. All you need is just treat this file as a list and just iterate to this. So for line in file, we are just iterating through the file and then printing each line. So the next is reading all the content inside the file as lines. See here, there is a difference between this and this. See here, for example, uh, you are forcing your file object to read them as lines. Okay, so file dot read lines. It means all the content inside this example dot txt, you are telling it to read it in line ways instead of reading it a content. So you don't need to worry about it. Okay. So now for line in lines, you are just iterating through these lines and then you are printing these lines. Okay. So this is the approach. So now after running this, yeah, we already ran this 42, hello world, 100, not a number, total lines for. So this is about reading. So now let's go to the writing content, writing part. Here I am in the same path, data. I am opening a file output.txt and the mode is write mode since I am writing into a file, and I am using this with keyword and I am using open. So you are telling file.write and file.write, this hello world is line, file written successfully. So now let's see. So now let's go to the path, go to the data path, and there is this output.txt file is created. And let's open it. Yep, this is the file. Okay, I'm writing two lines, hello world, and this is line. Okay, so I'm putting two things, hello world first file.write, and I'm putting here slash n, it means new line. And in the next line, I'm writing one more line, this is line 2. Okay, so now what if I run this again? So whether the content inside this file output.txt, it will be overwritten or it will append. Let's see. Okay, so now open this file again. I will just refresh. Okay, so output.txt. So again, I'm having only two lines. Why? Because a write mode means it will overwrite the existing file. Okay, so if the file is not there, it will create a file and it will write the content. If the file itself is not there, see, if you can see output.txt, I did not create a file. The file is not there. The first time it created the file and these two lines are written into the file. For the second time, the file is already there but I am overwriting the content. Okay, so please remember, first time output file is not there, it is creating a file and I am writing the content into the file. Second time I am just overwriting the content. Okay, I am not creating the file. If you can see our output, only these two lines are there. So that is what you can do in write mode. Same thing, instead of writing line by line, you can write all lines at a time. As we discussed in the read file, will can do operations on list also. You can put this in a list. Lines is equal to whatever content you want, all lines as a list. And then you can tell it file dot write lines now. Instead of file dot write, you need to put file dot write lines, and you need to pass these lines, which is the content of your file, entire file, not just a single line. So now if you run this, yes, you can see here data.txt is not there here. So now if I ran this file, data.txt is created. I will just refresh here. See, data.txt is created and the content inside is name, age, alias, 25, all the whatever we have written. Okay, so I'm writing this list into the file. So if I ran this again, yep, same will be there. If I just refresh just to confirm, yeah, the same content is, the file is already there. I'm just overwriting the content. Okay, so now there is one more file operation called appending the file. So here data.log.txt. So this file is also not there here. So what if you try to open a file in append mode, it will create a file if file is not there. Okay, and then you will writing this line. Okay, so now I'm printing. Okay, appending to log is finished. So now let's see what happens. So now let's refresh this again. So I'm closing this data output. Now there is a file created called log.txt. So new log entry. let it be. So now I'll write one more time. I will execute the cell one more time. So here what happens is in append mode, file is already there and the content is already there. It will just append to the content. It will not overwrite. So if I just refresh this, yes, a new line is added here. Okay, because I'm writing only once, and I told please open the file in append mode. It will append to the existing content. Append means adding from the last known location. Okay, this is about reading a file, writing a file, appending to the file. And in write mode and append mode, if file is not there, it will be created. And if you are using it second time, it will overwrite and so on. But in read mode, if file should be there. If file is not there, it will throw an exception. You must have the file. Okay, or else it will throw an exception. That's why we put here. So for example, if I put here example 2.txt, so that file is not there. And if I'm trying to read it, so it thrown an exception. Okay, file 2.read, no such file or directory. Okay, so that is a file not found error. So why this is not, why the program got crashed here instead of going to the exception? It's because the exception type I'm using is value error, but the kind of exception we got is file not found error. So here you need to add a code for one more exception file not found error. In that case you need to write. Okay, but I just want to show you, if file is not there and if you're trying to read, error will come. If you handle that error well using exception, the program will not crash. If you're not handling but still it throws the error, but it's not a good practice. So the better way is, yes, you need to handle the error properly. So that's what we are doing here. So I'm opening a file here, and the file name is log app.log. So if that file is not there, what happens here? Exception comes. So here I'm adding file not found error. Okay, my app.log file is already there here. Just before running that, I will just put app2.log and I will just run this. Yeah, see now this file is not there, app2.log. If you see here, app2.log is not there, but exception is coming. But this time maybe I'm putting the correct exception, file not found error, and it is throwing error. But program didn't abrupt wrongly or crashed, or we did know gracefully, as we discussed in file error handling. Okay. So now let's rename this back to app.log and then see now what is happening. Yes, file is there. I'm reading the file. And since like you can read the file in multiple ways, one is like iterate through the lines of the file. So for line in file, so the purpose of this example is I need to count how many. So this is my file. This is my app.log file. I want to count how many errors are there, how many warnings are there, how many information are there. So if you remember, we have already did this in earlier week 1 with string. So we read the entire content as a string and then we applied strip operation, join operations, and we did. So that is okay, bit lengthy, but with file it becomes much more easy. So you can put that entire thing into file, read the file, and automatically everything is line in file. So you can iterate to that file object and then you can just tell, okay, if error in line, what is meant by this? So in the line, so first the file is read and the first line is this error database. Okay. So if this string is there in this line, if yes, increment my error counter. If it is not, if it is warning, increment by warning counter. If error is not there, warning is not there, don't do anything. Okay. So in my app.log, I have error, info, and warning. Okay. So I'm not worried about info here. I'm just only worried about how many errors are there, how many warnings are there. So that's what we are doing. So we're just counting how many error lines, how many warning lines are there, how many errors or how many warnings. So I'm iterating through the file with the help of lines and then just counting it. So finally, I want to write the summary. So I want to write the summary means I want to write it into a new file called log_summary in the write mode, and I'm just updating my statistics here. How many errors are there? How many warnings are there? Okay. And finally, I'm returning this as a tuple object, error count, comma warning count. Okay. So now let's run this thing here. Okay. So it says analysis complete, errors 2, warnings 1. So this is my app.log file. I have 2 errors and 1 warning. And you can see here I am after I call this is a function now. Analyze log file. To this function I am passing file name, and this function is returning a tuple. Okay. If exception happens, this function is returning a tuple but zero zeros default values. If file is there, it will return the actual error counts and warning counts. So analyze log file, errors is 0, warnings is, since file is there, I'm getting errors to warnings 1. Okay. So I'm printing that errors and warnings here. If file is not there, you will see here 000. Okay. So yeah, you already seen that earlier. So I have to dot line that file is not there. So exception happens, and then analysis is 0 error, 0 warnings. Okay. So that's how this file not found error will help in handling the file errors properly. And there is a different ways, different syntaxes to read the file, lines, read, and then you can write to the file, you can append to the file. Okay. So yes, these are the common mistakes. Ensure the mode is correct. So when to overwrite, when to append. So keep that in mind, and don't forget to close files. Of course, with keyword, with the keyword, it automatically take cares. Yeah, in AML, there you will play a lot with data. You need to read lot of CSV files, lot of JSON files, lot of text files, sometimes lot of DB files too. So yeah, so let's keep practice on these file operations. Okay, we'll discuss about a topic called JSON handling, and we'll look into different methods, load and dump. So before going into the JSON, so let's understand why we need a JSON. See, this is a data stored in a text file, so name and age. But if you want to do some data operations, so what you need to do? First, you need to read this file and you need to apply some operations like strip and then read line by line and then do a lot of things. Depends upon the complexity of the text data in the text file. So it will take a lot of time. Even before applying algorithm on data, you just need to convert a unstructured data into a structured data. It takes a lot of time. So the better way is, yes, maintain a JSON file. So JSON means a structured data, structured lightweight data. Okay, or you can also call structured string. So that in the text file it is unstructured, but in JSON this is called a structured string. So that is the most simplest definition of a JSON. So JSON means it's nothing but it's a structured string. Okay, it's also lightweight. Since it is lightweight, since a string is lightweight operation in Python, you can use it for exchanging data. Okay, so the full notion of JSON is called JavaScript object notation. So JSON is nothing but a lightweight structured string format. Okay, but it also looks like a Python dictionary. If you come here, the syntax, everything, it looks like a dictionary. Okay, but dictionary is not a string. Dictionary is a type. It's a Python dictionary. It's a dictionary type actually. So that is not lightweight. It's heavyweight. Okay. So now yes, there are similarities for JSON string and there's a similar for a Python dictionary. But one is lightweight and one is heavyweight. Okay. So now let's see. That is about JSON and JSON, how a JSON file looks like. How and this is a JSON string actually. This is not a dictionary. It's because I am starting with the single quotes. So this is a JSON string, which means a structured string, and I'm printing this. Very simple. Okay, this is not a Python dictionary. Okay, but looks like a Python dictionary, but it's a string. So if you just print, go ahead and print type. Let's do that to print type of sample.json. Yes, see. So ultimately, this is a string, but it's of more structured. So this structure is called as JSON structure, or simply you can call it as JSON object, or just a JSON file, or JSON variable here. Okay. So it depends. Just naming notation. At the end of the day, it is a simple string, structured string. Okay, but at high level, it looks like a dictionary. But dictionary is a different concept. It's a Python object. So don't confuse between Python dictionary and JSON string. So, but the most important concept is if you understand this, you'll understand the whole thing about the handling JSON. So, about is how to convert a Python object into a JSON object. So, in a dictionary, if there is a dictionary, you can convert into JSON object. If there is a Python data type list, you can convert that into JSON. So, every data structure you can convert into a JSON object, or in other words, every data structure in Python you can convert into a structured lightweight string. Structured lightweight string. Okay. So now let's look. So this is a dictionary. Python data because I'm starting with this flower brackets closure and I'm putting all the data. So now to how to convert this heavyweight data or a Python object into a string, JSON string. So you will use this method called dumps. So using, yes, but this method is available under a library called import JSON. You need to import it before using it. So import JSON and use this method json.dumps Python data. So now if you print JSON string and the type, you will understand the difference. Okay. So now let's run this. You see, initially I'm printing my dictionary and of course the type is dictionary. So next I have converted this dictionary into a lightweight structured JSON string. So this is what you do, dumps method, and I'm just printing it, print type. Okay. Yes. Now the class is string. And now if you want to like, if you can use this indent is equal to 4. So that way you will see the difference. Okay. So this is like a JSON, lightweight structured string with proper indentations. Okay. So I will just repeat it again. So we have a Python object. This is a dictionary, not a string. So the aim is to convert a Python dictionary into a lightweight JSON object. Why we need conversion? In future or in real examples, we will use this string to exchange data and do computations very fast. Okay. So typically in client server applications, you will see this JSON object importance. Okay. So now let's see. So this is how you convert using this dumps method. So print, if you print this, you will see, okay, what each object. So yes, this is dictionary and this is string, or you can structured string, or you can also call JSON. This is also a JSON string, but I'm not using any indentations. So just to see the difference, okay, people might confuse, okay, this is dictionary, this is also a dictionary, but just to see the difference and true JSON structure, we are using this indentation is equal to 4. So it will keep all the indentations for each element. Okay. So this is how you convert a Python object into a string, a JSON object. So now let's look into how to write a JSON file. So to write anything into a JSON file, so first you need to convert this profile or this Python object into a JSON string, or else you cannot write it. So now let's see that. So for example, I am reading this file, I am creating a file user profile.json. So let's start writing this. So now I just write user profile, which is a Python object. You can't write it. So if I just executing, so it will tell, okay. So I can't write must be str, not dictionary. Okay. So now you're trying to understand in file operations, if you want to write a Python, a dictionary, okay, you can't write it into a file because it is a dictionary object and it's a heavyweight. Yes, you can write. You need to iterate and then you need to read these keys, read these values, print it and properly go. So that's a very, very costly operation. Okay, it will take a lot of time. So the much more simple ways you convert this data into a JSON string. So what you need to do? You need to use this. Okay, so if you use this JSON dot, so same JSON dot dumps user profile, this I'm converting into JSON string. So this string I'm writing into the file. Okay, so now let's run this. Yes, JSON data save to user profile.json. So this is my user profile.json. You see, so here indentations are not there because I have just written it in a single line. Okay. So now let's put proper indentations here, so that way it is more human readable, and you are keeping the true JSON string. Okay. So now let's run this again. So I'm putting indentation. Now it is like more structured. Earlier also it is structured, but no spaces. This is with proper indentations. So it is more human readable if you keep indentation. Okay. So now let's, so but when you're dealing with files, there is one more method called dump. So what you can do is these two lines, JSON dot string, JSON dot dumps, and then first converting that. So you can replace these two lines into one line. JSON.dump, user underscore profile, and you need to pass this entire file object, and indentation is equal to 4. Okay. So with this, you can just convert directly this user profile into a JSON string and directly write into the file. You don't need these two steps. So these two lines are represented in one line called JSON.dump. So now let's run this again. Okay. So now the data is written successfully. Since it is in write mode, I'm just overwriting the data every time. I'm not just appending the data. Okay. So this is how you write the data or into a JSON file. In other words, I can tell this is how you convert a Python dictionary into a JSON string and writing that JSON string into a file. Okay. Or in simple, writing data, dumping data into a JSON file. Okay. So the JSON file means the extension is profile.json. Okay. So now let's look at how to read data from JSON. Okay. So I have a file called settings.json like this. So theme, language, notifications, and volume. Okay. So this settings.json. Okay. So how do you read it? So the method is from file. How to read from file? Load. To write it is dump. To read it is load. So now just let's. So with open data is equal to json.load and print is I'm printing this data. So I'm getting all the data. And by default, what is the type of this data? Is this a string or a dictionary? So this is a dictionary actually by default because we are reading from the data. We are reading the data from JSON file. So by default, if you are reading any data from the JSON file, it is automatically stored as a Python object, not a JSON string. Okay. So while writing into the JSON, you need to convert the Python object into a JSON string and then write it into the file. But while reading, it will automatically take this load function will automatically taken care. By default, the data it will be dumped into the Python dictionary. Okay, so that is the advantage you will be getting. So now what happens if I try to load user profile.json and then so let's do one small thing here. First let's run this. Okay. Okay. So here again. So I have this user profile.json, which is like this. So I am loading this file load.json.f. So this load method is under import JSON. So I'm printing the data and the type is dictionary. Okay. So now let's do one small example, which will tell you one error case will reproduce. So, yep. So let's write this. So I'm executing this cell again. So here I'm writing two lines. In first line, I'm telling, okay, convert this and just dump without indentation. And here I am using this dump method and write with indentation. Okay. So I'm just executing this. Yes, JSON save it to user profile.json. So now this is my user profile. I have two lines. I have two strings. One is this structured and this is also a structured but without no indentations. Okay. So now let's try to read this JSON file, user profile.json. Okay. You see, the error is coming here. It is telling what kind of error? JSON decoder error. It means it is not able to read this particular line. Without indentations line, it is not able to read because, okay, I'm expecting the format like this, but in the file, the format is like this. I'm not able to read. So that's why it is complaining. Decoding error. Okay. So be very careful while loading the JSON file. Ensure that JSON has a proper structure. Everything is properly structured and proper indentations are maintained. So that's why while writing into the file itself, you just need to ensure you write it that string into proper indentation. That's why I'm using this indentation symbol. Okay. So let me. Okay. So where is that? Okay, the cells got hidden. So let me click this. Okay. So now let's go to this user profile.json and then okay. I saved this file, user profile.json. Yes, that's why now the cells will come again. Yeah. So now let's try to read this JSON file. User profile.json. Okay. So now let's go to this user profile.json and then, okay, I saved this file, user profile.json. Yes, that's why now the cells will come again. Yeah. So now let's try to read this JSON file, user profile.json. Yes, that's why now the cells will come again. Yeah. So now let me run this. Okay. Interesting. What happened to the cells? Okay. It's fine. No problem. Mm, okay. Yeah, it came. Sorry, I clicked one wrong button. Yeah. So now let's come back. So what happened here? So I removed that f- string format, structured string, which is doesn't have any indentations. Now I just kept it with indentation. Now I'm just rerunning this cell again, which is read and then okay. Now just execute. Yep. So now I'm able to load the JSON file properly. So what we have seen here, yes, the JSON file should even it should be more structured and indentation should be maintained in the JSON file, and all the key values should be there. So we'll see that error later. Okay. So now we see here one error while reading the JSON file, like decoding error. Okay. So now let's look more into JSON strings. So writing here we are writing this JSON, and then let's see how, and here we are reading from the JSON. Okay. So this example shows how to write data into JSON. So before writing, what you need to do, and here this example is showing how to read data from the JSON and JSON dot load, and we need to ensure while loading what kind of precautions you need to take. That JSON file should be correct, or else decoding error will be coming. Okay. So now let's look into what kind of other errors are might come, but before that let's look into one more method called JSON. So we have seen in this top how to convert Python to JSON, Python object to JSON. So now we'll convert JSON to Python. Okay. Of course, this is already covered here. JSON to Python means nothing but, yep. Let me come down here. Yes. So you are automatically converting this into a dictionary. You don't need to again. Okay. So from the file, if you're using JSON.load, already the JSON string, whatever you're reading from the file, it is automatically converted into dictionary. Okay. But what if you have a JSON string, and how to convert this into dictionary? Same thing, you will use the same methods, JSON.loads. Instead of load, you will be using loads. See here, I have a JSON string. I'm not reading from file here. If you're reading from file, directly the string will convert to dictionary. That example we have already seen here. So dictionary. Okay. So if I have a JSON string, if I load it, does it automatically converts? Yes, but you need to use a different method called JSON dot. My bad. You need to use a different method called JSON dot loads here. It's as simple as that. So now let's start executing this. Yes. So this is my JSON string, and I'm converting that into a Python dictionary. And here also I'm converting that into a Python dictionary, but I'm just adding indentation here before converting. Okay. So hope you understood the difference between Python dictionary and JSON object, and how to convert JSON to Python and Python to JSON. What happens in case of file is the conversion is automatic. Okay. So here JSON.load, it will read JSON object or JSON string, the structured JSON string, and it automatically converts into Python dictionary. Okay. So here I have, instead of reading from file, if I have a JSON string, I need to use a different method called JSON loads. This will ensure I'm converting this JSON string into a Python dictionary. Okay. You can see the difference here. This is just indentation I'm adding. So in the first case, I have a Python object. To convert this into a JSON string, I need to use dumps method. So this will take in care, and this is with indentation. Okay. So here, this is about reading and writing. So before writing, you need to ensure I am maintaining proper indentation. If there is no proper indentation, if you use directly write it into a file, the JSON string, while reading, you will get errors. So that's what we have seen here. So while reading, we seen some JSON decoding error. Since the file is proper, we are not seeing any errors now. And this is just one example of reading. Okay. So just ensure you are following the JSON structure, reading everything properly. Hi everyone. Welcome to the module Python file operations. Today's topic is CSV processing. So how to read data from CSV and how to write data to CSV file. So we'll be looking into different methods: CSV reader, writer, dictionary reader, and dictionary writer. So before going into the practicals, let's see what is a CSV. CSV means it is comma separated values. See, let's say if you have a data like this, more precisely you call this as a tabular data. So because you have name, age, and city, and all the names you have in this column, and all the age and all the cities. So it is like a tabular data. So whenever there is a tabular data, you need to store that in a CSV file. Okay, so it is easy to process, read, and write. Okay, so now let's start looking to the basic things how to read and write from a CSV file. Here I have Here I am importing a library called CSV, which is Python inbuilt. You don't need to install using pip package. Import CSV, and we will be calling certain methods: CSV.writer, CSV.writeRow, and CSV.reader. Okay. So now let's see how to open a CSV file and write the data. So with the files, you use this keyword with open as file object, and the file name I'm opening is data employees.csv. Okay, so as I discussed earlier, this is a relative path. The data folder should be there, and employees.csv file, if it is not there, if it is, it will get created, but data folder will not get created. Data folder should be there. Okay, so now what you need to do, you need to call this csv.writer with, so I'm creating an object called writer object, initializing the writer object as CSV writer. Okay, this writer is nothing but a CSV writer now. So how do you write data? So writer dot write row. Since this is a tabular data, CSV means a tabular data, comma separated values, tabular data like this. So you need to write data row by row. Okay, because in table you will be having rows and columns. So in that aspect, we need to write each row. So writer dot row. First I'm inserting this row, which is the header, name, age, and department. So next I'm filling the next row of the table, which is name, actual values, and I'm so on writing other two rows. Okay. So after first let's compute this. Okay. So now let's see where is this file, employees.csv. Let me open. So file, open, and then yeah, I will open this file inside data employees.csv. Yeah. So this is my file. So this is the first row, second row, third row, fourth row. Okay. So I have different rows. This is called tabular data. Okay. So now after writing the data, we need to read the data from the CSV file. So now I am opening the file in read mode. So the method we'll be using is reader. So csv.reader, read the file, and this is the reader. Okay. So now how to print the data from the reader object or reader variable, which is of type CSV. So simply you need to iterate through rows. So this reader will store the data in the form of rows. Remember, not lines, but rows. So for each row in reader, I'm just printing. So first row will have this, second row, third row, fourth row. So each row is a list. Okay. Because here in writer row, we are writer dot write row, we are writing it as a list. So I'm sending this entire table, row 1 table data as a list. So row 2 entire data as a list. Row 3 entire data as a list. So that's why while you're printing row, you are seeing the list objects here. Okay. So that's how you read the data and you write the data into a CSV file. Very simple example at high level. Okay. So now let's play with CSV other methods. Okay. So there is a one more thing called CSV. Instead of CSV writer, you have one more initialization object called CSV dictionary reader. So what is meant by dictionary reader? Dictionary reader means here it converts each row into a Python dictionary. So this row will be converted into a dictionary. This row will be converted into a dictionary. Okay. So CSV dot dictionary reader. This is a very helpful method if you want to do any operations on the data, or if you want to print any explicit details. So first let me comment this and then just run this. See, this is my employees.csv file. So this entire row is nothing but a dictionary. But since dictionary, it should have key and values. So this is name, this is age, and department. Okay. So this is a very nice representation. So in dictionary, remember, the size is 3. If you're reading directly from the CSV file with a normal reader function, the size is 4 because header is also coming as a row. Okay, here header is integrated into the elements, into the rows. Okay, so here name is Alice, age is 25, like that you will get more details in the form of a dictionary. So each row is converted into a dictionary with with corresponding key names. Okay, so now what happens? So because, so now let's comment this and now just run this, see what will happen now. So here I am trying to print row of name. So it is going to the first row, and row of, what is the row of name? Yes, the dictionary is, what is the, here I am reading the value key. So what is the name is key, and what is the value Alice, and what is the value of row of department engineering. So you will see Alice engineering, and you will see the complete, let's see the complete log now. You see Alice works in engineering, Bob works in sales, Charlie works in engineering. Okay, so from the given tabular data you can filter out whatever data you can, and you can filter it accordingly by using this dictionary reader. So dictionary reader means each row is converted into a dictionary with their corresponding header information, key and value pair. Okay, so this is one way of reading data from the CSV file. So let's see some more approaches. See, now we have a data which is a tabular data. So this is this data type is a list of list. So this is list, inside list I have one more certain list. So it's a two-dimensional list. So how do you read data from this? So it's simple, CSV dot writer, and then CSV, I mean, I'm writing data into the CSV file. So what is the data I have? This is the tabular data I have. So here, so you just need to open the file in write format, and then my file name is products.csv, and I'm initializing the object csv.writer, and then I'm writing all the rows at a time. Earlier I am writing each row, like write row 1, 2, 3. I'm writing it separately. So now what I am doing, I am putting all this data into a tabular format with the help of a list data structure, two-dimensional list data structure, and then I am writing that entire data at a time using writer.write rows. Okay, so if I print this now, yes, the data is returned to products.csv. So let's open this file, open. So it is products.csv. Okay, so I'm able to get all the data. Okay, so yeah, so here I can see products.csv, all this data is written into file. It's a comma separated as a rows, product, laptop, mouse, keyboard. Okay, so you can also open files from here. So if you from Jupyter Notebook also, yeah, it is taking time, but yeah, here you can see product. So these rows numbers is automatically added by the Jupyter Notebook. So just to avoid confusion, I just plainly opened it in a note edit in a different editor called Sublime Text. So it is very clear for you, like, okay, so what are the each rows coming. Okay, so now let's see how to, yeah, so we have a data, tabular data in the form of a list. We have written the data. You can write multiple rows at a time using writer rows. If you want to write row by row, you need to use writer row. Here we are using writer rows, right? Rows. Okay. So now next look into how to write CSV with a dictionary writer. So far we saw dictionary reader. How do you use dictionary writer? So here we saw dict reader. So now let's look into one more example of dict writer. So dictionary writer means we can write a dictionary into a CSV file. Okay. So let's see. Here is my data. So I have a list, and this list has different elements, and each element is a dictionary here. So I have a dictionary, a list of dictionaries. Okay, so what I will do, yes, I need to write it. So I need to open the file in the write mode, and this is the, so before initializing the dictionary writer, since I am writing a dictionary, I need to initialize the field names. Field names means which is the table heading. So my table heading, from this I can tell username is 1, email is 1, and role is 1. So these are my field names or heading of the table. So then you need to initialize the writer. So what is my writer? So in this case, I want to write a dictionary into a file. So I need a dictionary writer. So initialize. Here I need to pass this one more parameter called field names is equal to this field names. Okay, don't confuse what is this field names equal to field names. Field names is like, you see in the functions we use this named arguments. So this is my named argument, and my argument value is field names. Okay, here both are same, but you can give here a different name also. But not to avoid confusion, I just created both as same names. So here I am passing field names as one of the parameter, which is nothing but the header of the table, and I'm initializing my writer of type dictionary writer. So now first we need to write header. So this will write this header, and then next I need to write all rows at a time, writer dot write rows users. So this will ensure it will remove the keys and only write the actual values. Okay. So let's run this. So the file it is saved to users.csv. So let's go and open file, open users.csv. Yes, see my entire dictionary is now converted into a tabular format. Header is my first row, and the next row is the information. Okay, which is nothing but the values of that particular dictionary. Okay, so using dictionary writer or dict writer, you can write a dictionary into a CSV file. So the methods I used is write rows and write header, both are same I used it for list. The only difference is here we did not while writing we did not put any field names, because already that data is in the neat tabular format. Here the data is not in the tabular format, it is in the format of dictionary. So that's why I have initialized a writer here, a header, field names, and this is my field values. Okay. So let's see one practical example of how to use the CSV reader writer. Here I have a data, sales data, so which is already a neat tabular data. So this is my header, and these are my values. Okay. So yes, so first I will read the data. Okay. So since the data is in the neat tabular structure, I will just use normal writer instead of dictionary writer. So and I will write the data at a time, all the rows. So this data goes to the CSV file, and yep, this is the information. So like that. So this is the information sales.csv, where all the information is written to CSV file in a comma separated format. So next, here is the interesting thing. I want to filter. From this I want to get the highest sales. Okay. So it means like, okay, what are the sales, total sales, like 5 into 50,000 to 2 lakh 50,000, 20 into 500,000. So I like 10,000. So I want to get the sales which are greater than 10,000. So for that, what I will do is first I will just, since I want to do some computations on the data I read, so the most appropriate way to read is using dictionary reader. Okay. So instead of csv.reader here, since reader means all the data will be in the rows, and then again you need to iterate each rows and identify what each value is meant for, it is bit tough to do some filtering or computation. So that's why from CSV file I am reading the data using dictionary reader, because each row is now converted into a dictionary. We have already seen that example. So now using that dictionaries, so for each row is a dictionary. So for row in reader, so first I will compute total value. So to get the total value, I will read this key value row quantity into row price, so which will give me the total value. So for example, here I will get 5 into 50,000, which is 2,50,000. That is my total value. If total is greater than 10,000, so it is a high value. So here high value is not but empty list. So now we will populate this high value list. So first I will append this high value. So what I will append? I will append, okay, what is the sales information? What is the product that I have sold, and what is the total sales I got? So this information I will append to this high value. Okay. So while appending, I'm ensuring it's a list. To this list, I'm appending a dictionary. So I will say it's again a list of dictionaries. So high value means product and the total name. So like that, for each row, it will do this computation, and with the help of since each row is now a dictionary, you will get product high value. Okay. So now let's write this high value into a file called high value underscore sales.csv. Since this is a of type now, since the high value data is now a list of dictionaries, so what you need to do, you need to write dictionary writer. Okay. So now let's start writing this. So to write the data, so first I need to open a file, high value sales. I need to provide the field values, product and total are my field values. These two are my field values, and I need to initialize the dictionary writer with the field values, field names, and then I will write the header first, and I will write the entire rows first. So here my rows are from the, where is the data? Data is in the high value, because I want to put only high value sales which are greater than 10,000. So where did I got this data? I got this data from the initial CSV file, sales.csv, and I read that as a dictionary, and then I computed from that one more table called high value sales and writing that into a CSV file. And here I am finally printing that values here. What are those sales values? So I am just iterating to that high value, which means I am iterating that list, which is each list is a dictionary here inside. Okay. So these are my high values: laptop, keyboard, and monitor. And let's see what went into this file, high value sales.csv. So file, open, high value sales. You see, product and total. Okay. So just remember, if you want to do more computations after reading the data, better use dictionary writer because it gives an advantage of converting each row into a dictionary. If you want to just do some very basic operations, you can just use CSV dot reader, which we did here like this. Okay. So that is about CSV reader writer and how to use it in practical cases. So now let me show you one more example where you can combine CSV reader and a text file. See, here is my tabular data. So here I am writing this data into a text file also. So just want to show, okay, if I have a data like this, am I limited only to write this data into CSV file, or can I write into any normal text file? Yes, you can write this data into a text file also, but you need to put some more thing, like you need to put this delimiter is equal to tab t. Since it's a tabular data, we want to clearly mention tabs properly such that it looks like it more of a tabular data. Yes, okay. So here I'm writing CSV dot writer. I'm initializing this with a delimiter, and I'm writing this entire rows information. Okay. So everything is same. Additional thing I just did is I just put this delimiter, and instead of writing to a CSV file, and I am writing here to a text file. And same thing while reading the data from the text file, if that it has more tabular data, you can also use CSV reader in that case also. So CSV dot reader, and then you initialize it, and then you just read it by row. Only thing is you need to put like this. So what I'm trying to say is, using CSV writer or CSV reader, these methods can also be to use it to do operations on text file also. Okay, but in general you will be using it for CSV only, but just letting you know. Okay, so we can, this feasibility is also there. So now let's run this. Let's open this file scores.txt once. Yes. See here. So tab. I'm putting tab here. That's where this thing came. Okay. So name is Alice and Bob, and score is 9587. See. So you can also write the data with the into a text file using CSV writer also. Okay. So that's all on the CSV operations, and the key takeaways are: yes, CSV is simple, universal form, used for tabular data. These are the different methods. Yes, in AIML, these are the most common data you come across. Hi everyone, welcome to the module Python file operations, and we will discuss about working with directories using pathlib and OS built-in libraries by the Python. Okay, so what is meant by working with directories or pathlib? Okay, so see, this is my working directory. So I have a directory called pycore, and this is the path. So how can I manipulate this path? How useful that path will be in file operations, we'll see. Okay, so to organize files inside a folder, and to check if file exists before reading, and to create some directories and process different multiple files under directories, and clean up any temporary files. Okay, so these are the operations you will be doing with your directory system or your paths from the system. Okay, for that you need pathlib and OS. Pathlib is a more of a modern way, OS is bit legacy way. We'll see both the examples. Okay, so now first let's start with the modern way and the most recommended way using pathlib. So before going implementing these details practical, so let's see one important thing from pathlib. See, import pathlib. So let's see what are the classes or submodules available in the pathlib. Okay, if you can see, pathlib provides these many classes, path, POSIX path, pure Windows path sequence, all these things. But since we are working on Windows, or I mean, we just require this one particular library path, one particular class path from the entire pathlib library. So we don't need this all things, and we don't want to unnecessarily load all the things and make things confuse. So for that specific reason, so I'm just importing path from the pathlib. So what is meant by this particular from pathlib import path means I'm just importing these particular class from the pathlib. Okay. So with that we will proceed. So see, I am working on a file, a Python file. So what is my current working directory? In which directory my file is there? In order to know that, you need to use this command path.cwd. So where is this path coming? From here. So path.cwd gives the current working directory. Okay. So first let's run it. Yes, this is my current working directory. This is where my Python file is there. Yeah, this is also the directory name. Yeah, don't worry. So D workspace. This is entire thing is my where my file or the current working directory is. So now you can create paths using path. See, so path of data. It means in the current working directory, you are trying to add some path. So in the current working directory means the current for the current path, you are appending a path called data. So what this does? So path of data, it means what it will do. So if you print this type, this will be of, so you can see this is a class Windows path. Okay. See, this path of data is returning a variable. The path of data, this particular path object is being written to the data directory variable. So that is what you are been seeing here, class pathlib Windows path. And yes, this is the type actually. Okay, the type of the variable is this. And if you print the data directory, you will just get data. So which is what our data directory is. Okay. So but if you want the entire absolute path where I am gonna create the data directory, so this is what. So you see, to the current working directory, the data directory path is getting appended. Okay. So I'll just repeat once again. See, path means it is used to do certain operations on your path or some directory operations. What is there inside your directory? How many files are there? How many text files, JSON files, CSV file? What is your current working directory? Where can I create directory? So like all these kind of the operations you can do using the path library. So first step I did is I got the current working directory, and the second step I got, okay, I have declared, I have called this class path, and to the class I am passing an argument called data. This is nothing but you are creating a path, but I am not using that path yet. I'm just creating a path. So if you just do like this under the current working directory, it will create that path. So that is what we are doing here. Okay. So this is just a variable as of now. So this path is as of now, it's just just a path object. We are yet to use this object, but what you can do is just showing here. Okay. So how to use this, we'll see in the next example. So now let's create directories. Okay. So now from pathlib again I'm importing path. So you see here path of data, it means under the current working directory I'm gonna create a directory. Mkdir means make directory or create directory. And I am passing here one argument exist okay is equal to true means if there is a directory already called data, don't create it. If the directory is not there, then only go ahead and create it. That's what this line means. Okay. So path of data, so in the current working directory, you create one more directory called data and create it if only directory is not there. So if you go here, see, I'll just refresh just to ensure there is nothing here. Yeah, the refresh is, yeah, I don't have any data directory here. So let's see. And you can also create subdirectories, directory inside a directory, directory inside a directory. Using like this also you can create, but you need to put one more additional condition, parents is equal to true. It means, let's say here in this line I'm creating a data directory. So the next time it is coming, the parent directory is already there. Okay. If it is there, also go inside and check if output directory is there. If not, create it. And go inside again output directory and check if results is equal to true. If it directory is there, create. If not, don't create. So recursively it checks whether the parent directory is there or not there. So path data is to create one single directory mkdir, and in the path if you give like this, the path all subdirectories will also be getting created. So let's check this once. Okay, so directory is created. Let's quickly confirm. Let's refresh here. Yep, the data directory is there. Output results. Yeah, so only the directories are created. There is nothing inside the file actually. Okay, nothing inside the directories. So now with the path, we have just seen how to create directories, subdirectories, and how we are making use of these arguments exist OK equal to true and parents equal to true. And during file operations, it is also useful to check if before reading, writing, or appending any file, it is important to check if file exists or not. So for that also, you will use this path. So from pathlib import path. So this is my on the current working directory. I created a data directory. I didn't create. I'm just initializing. Okay, there is a for directory under the current working directory called data. Okay, so before creating anything, so I'm just manually checking if data underscore path exists. Okay, so data underscore path, these are all the Python built-in functions, okay, provided by the path class. So here after creating, it will return a object as we discussed in the above example. It will return a class object like this here. Okay, data dir, because data dir underscore absolute is one built-in function, and the other built-in functions are exists. It checks whether the data directory exists or not. Okay, and it tells okay, not dead if the path exists. Okay, and now is data is a directory. Okay, and if it is a file or not. So I am also checking. Okay, under data I'm asking whether there is a file called config.exist. If it exists, it will return true. If not, okay, it will say doesn't exist. Okay, so simply I'm just creating one path called data under the current working directory, and I am checking okay if that path is already exists or not. It should exist because slash data directory is already there. So I'm just double checking whether is it directory or not. So path is there. That can be, sometimes it can be file name or it can be any other thing. Just cross checking is that a directory or not. And I am also checking in case is there is any file name with that same name. Okay, so here I am also checking explicitly. I am checking whether this config.txt exists or not. So this is used to check whether is any file is there, directory is there, like that. So it says see data directory exists true because we have the data directory. And then is it directory? Yes. And is it a file? No. And data config.txt exists? No. I don't have any text file here. So next we will see how to list directory contents. So before listing directory content, let's create some dummy files. See, this is one more way of creating a file. Using you can also just open the file. In the last class we have seen file dot with file open as, so that it is used to create file also. This is one more way. Okay, so write text. So what I am doing is inside the data directory I'm creating a file 1, and inside a data directory I'm creating a file 2, and I'm creating report.csv. The syntax is path. Okay, so to this path, so this actually is doing nothing. This is just returning a Python path object. So to that path object I'm calling one more function called write text. So this just creates an empty file. It's not even creating empty file, it's just declaring the path. Okay, under this data I'm about to create a file, or I'm just initializing a path called file1.txt. So now write.text is doing the magic for us. It will create the file, and then inside that file it will write the sample one. Okay, so this is coming from path. Okay, from path library itself. So same here. Okay, so here I am writing some table name, age, and in the next line I am telling /n means next line, li is 25. Okay, so now what I am doing, I'm trying to list all the items. So how many, what I will get file 1, file 2, report. Okay, so how to list all the files inside a directory. So you need to use iterator dir. Okay, but you need to create this path object first, data dir. Okay, so this is already there. So data dir is nothing but path of data. Okay, so where the data folder is there, that object I'm returning here. So data dir dot iterator directory. If you call this function, you can see what are all the items inside a list. Okay, so this will return a list. I'm just iterating to the list for item in item dot name, and item is directory else it file. Okay, so let's run this. Okay, so first let's check what happened inside the data folder. Okay, this is my data folder. See, I have file 1, file 2, report.csv. So inside file 1, okay, this is file 2 and this is report. Okay, so let's see, file 2 sample 2, file 1 sample 1, and report.csv is, I have one name, a table name, age, like alias and 25. Okay, so all these things are created with the help of this path library, not file type. Okay, write sample 1 and write sample 2, and whatever path is there here, it will create in that particular path. Okay, and here I am printing. Okay, so this data dir underscore iterator, it will list all the files, all the contents inside the data directory. Okay, so because I'm telling path of data here. Okay, so this is how you print it. So next we will see how to, using this path class, how to find specific files. Okay, specific file means, see, here we have text file and CSV file. So how do I know how many text files are, or what are the text files are there? Okay, so for that, very simple, it's again, you just need to create a path directory. Okay, data, and then yes, here all text files is just a print line. So for text, so data underscore dir dot glob star dot txt, for text file, print the text file name. So this, as we mentioned, this data directory contains list of all files. I am just iterating here. Okay, in the same way, so this path object, so what I am telling it, data glob dot star txt means, so what this function will do, so this will return list of all the files ending with .txt. So it's glob means like a function which is provided by this path class. Okay, so this path class, with this path class I'm creating a path object here. So now with the help of this path object, I'm trying to filter all the, I'm trying to get the list of all the text files. Okay, so this will print the list of all text files, and same way you are telling recursively. So there is one more function, or glob. See, here you have a files directory, inside a directory, one more directory. Here you have, so here are some list of files are there. So like that, here I am telling recursively search need directory and print all the things. Okay, okay. So here inside directory I don't have anything. Okay, what it is empty. So for now it will just only fill whatever inside here, file 1, file 2, report.csv, because I don't have any files inside output directory. Okay, so let's now run it. Okay, so this is what we have actually. Yeah, so what is this file 1 dot checkpoint? Yeah, this is a temporary file because we just opened the file. Yeah, no worries. But yeah, so what all text files? Yes, inside the data directory you have all the text files, file 1 and file 2, and this is recursively. So see, this is very important. All recursively means we have this dot folder, right? Dot IPython notebook checkpoints, dot IPython notebook checkpoint. So we have this folder, we have this directory. So recursively we are searching inside data directory, inside it is the any text file. So we are listing those also. Okay, so that is the power of recursive global. So what we did, we are finding specific files, specific text files under the current working directory, and in specific under the directory data. Okay, so yes, you can also do path manipulation. So let's say this is your current path now, data output results report.csv. Okay, so I can see what is the full path, and what is the file path, and what is the file path extension, what is the suffix, what is the parent, and how do you append a path to it. So let's run this example and then we can discuss one by one. Yep, see, full path is equal to, this entire path will give the full path. Okay, file path, sorry, I mean I'm so file path is equal to data output results dot csv. So this returns the Python object, and if you try to print this file path, under this flower brackets, it will give this. Okay, it will give the path, full path. Okay, but what if I just only want the name, this just this name, file name? So this will give file name dot file underscore path dot name. Okay, see here. And what if I just don't want no extension, without extension, how to get the file name? So you should use file underscore path dot stem. Okay, just report dot csv is the file name. So file under path underscore path dot stem, just give the file name without extension. How to get only extension? File underscore path dot suffix. So this will give only extension dot csv. And how to get the parent? Parent means this path. This is called parent, where my file is. So this is parent. Okay, so it will give data output results. Okay, if you want absolute path also, entire path, you can print it, but you should use that method, absolute method. Okay, so now I want to add one more thing here. So how to create any new path? Okay, so you can create a path like this, a new path, or you can also create a path like this, path of data / logs / app.log. So these both are same, but just showing a different flavor. Now the joined path is equal to new path, which is nothing but data logs app.log. Okay, so this is just creating a path. I'm not creating any files here. Okay, the file is created only using this particular method, write underscore text. So here I'm all just telling, okay, in this particular path my file is there, and inside this directory my file is there. Like that, I'm just giving an information, initialization things. Okay, so this is how a file path is. Okay, how can you play with the file paths? Okay, and next we will see one practical example. How do you organize files by extension? See, I have a path data. So inside data, I'm telling doc1, create a file doc1, and then write text document1, and just initialize a path, go to that path, write some text, initialize a path, data.csv, go to that file and write something. So I'm telling, okay, create under data folder, create 2 text files and 2 csv files. Okay, and later I am telling, so the goal is how to organize means, so all the txt files will go to one directory and all the csv files will go to other directory. So how do you organize? Yes, so here I am iterating through the directory. So this is the path object. Using iterated directory, you can iterate, which will give the list of all the things. So I'm iterating, and if this file is file, if it is a file, first get the suffix without dot. Okay, because if the file name is .csv, so what I'm trying to get is get the suffix without .csv, because I need to create a directory csv, because our aim is to organize this. So under csv folder I will write csv files, under txt folder I will create I will move these files into the directory. So how do I know which directory to create? That depends upon the file extension. Okay, so I need to iterate entire files and see what kind of actions are there. So that is what I am doing. So this is my current path source directory. So this is the function we are calling, organize files by extension, and this is what is the argument I am telling? Data. So it is trying to check what are all the things are there inside the data. So the date it is passed here. So my source directory is there. So entire directory object is there, and first I am iterating how many files are there. So if it is a file, what I am telling, just get extension and then create a directory with that extension name. And now what is this? If it is an extension is there, so then I am telling create source / extension. It means under data directory I'm creating a csv folder, and under data directory I'm creating a txt folder. So this is how I'm creating external dir mkdir. Okay, so now after creating the directory, so I need to move this file. It's a current file. I move this current file name into this new directory, because the task itself is to move all these things. Doc1.txt now should be under doc directory. Data1.csv file should be now under csv directory, because I'm organizing. So how you organize? So this is my new path, and this new path is okay extension directory. It means data / csv, and then in that move this file name. So this is equal to data extension directory underscore CSV, and file name, what is the file name? Data1.csv. Okay. So here what I am telling, so if it is a file, create directory, if extension, so this extension will be CSV, just example I am telling. And here what I am telling, under data slash CSV. So what I am telling here, create a new directory, data slash CSV, and I am creating a directory here. Okay. So finally we got under data underscore CSV, we are moving this file data1.csv. Yes, this is the new path. I just don't need this. And okay. So if the path exists, okay, what happens? Rename the new path. Yes. And then move the file. Okay. So the file dot rename of new path means it's just like copying, it's like moving the file from one location to other location. Okay. You are not copying here. Okay. So let me repeat this. So this is the data1.csv. So now you are telling if not new underscore path dot exists. Okay. So this data1.csv is not there inside this data underscore csv. If that is true, yes, then come inside. I mean, the file is not there, not of false is true. Come inside and then file dot rename new underscore path means this original file. What is this original file? Data1.csv is now moved to this data1.csv. Okay. I mean, data underscore csv. So in other ways, what is happening here is data underscore data1 dot csv is now moved to this above path. Okay. Okay. Because my file is this. So where I am getting this file information? From the, I am iterating. So it will go through, it will check for all the files. Okay. For all the files, this for loop will repeat. I'm just showing for one file, data1.csv, what happens here. Okay. So now, yes, finally, now the file got moved to this directory, and finally we'll get this, all entire for loop is run. So finally we will be getting all the files are neatly organized. And now I'm just printing. Okay, what is my organized structure now? So I'm just printing all the contents now. Okay, so now let's run this. Wow, see, lot of things are coming. So first we'll check what happened inside the data directory. So two folders are created, CSV, TXT. You can see there are no any files here. Okay, and then output is, this is still empty because we are not doing anything here. And inside data, all the CSV files are there. So this report.csv is earlier generated, and this data1 and data2 is also generated, but it is here actually originally. Same thing with the text. Okay, now all the text files are here. So it is now neatly organized, CSV, TXT. Okay. So now what is this? Yes. So under data directory, I am printing everything now. Okay. Now under data, what is the structure? Yeah, this is for renaming the file. So this is actual what is there inside my structure. So I have a hidden file, hidden folder dot I Python notebook. So in that I have these three hidden files. Yeah, these are like temporary files. And inside CSV I have data1, data2, and inside CSV I have this. And inside text I have doc1, doc2, file1, file2. You see? So using path underscore r globe structure, I'm just listing whatever all the files are there. Using globe, you can also use. But it will not go directly inside that. It will not check files under nested directory. So here I am using reverse globe. Okay. So this source.iteratory directory is also iterating, but you will be having file object here. So, but if you are using r globe, it will be not having file object. You will get just a file info actually. Okay. So next, yeah, traditional approach. Yeah, nowadays we are not using this OS approach, but it is good to know. In OS also you got os.getCwd and OS is exists. If you say directory, same thing. Whatever they are in the path, you can also use using OS. And then this is also same. So whatever using path, we can also use OS. So yes, this is the import OS. So is walk of data count. So this is very old way, but I'm just letting you know, okay, such mechanism is there. You can just go through it. But yeah, so the ultimate thing is using path, you can organize datas like this. And how to iterate, you can use globe, r globe to iterate to see what are the contents inside the file. And using this dot iterated directory also, you can recursively you can just iterate whatever files, but you will be getting more operations. Okay, so this is what are different file names: file path, file path dot name, file path dot stem, file path dot suffix. So like that, everything you will be getting. Okay. Mm, so what? Yeah, that's all for the path operations. So now there is one more topic pending on Python file operations. So let's look into that in the next class. Thank you. Hi everyone. Welcome to the Python file operations module. So today's topic is file error handling. This will be the last topic of the Python file operations. So over this module, we have discussed a lot of things like how to open a file, read a file, JSON file, CSV file, and how to make use of path library, and how to create file using path library, and then a lot of things we have done. But we really didn't work on in depth about file, how to handle file exceptions, and what is the better way to do file operations. Okay, so let's quickly check that. So currently my I don't have any data folder here. So just to work on few basic things, first I will start with creating a simple file, example.txt, and the content is hello.world using path library. Okay, so first let's run this. Okay, so the setup is complete. Setup means I'm just, this is it, like just creating one sample file so that I just play with it. Okay, so yes, the data folder is there now. Oh, it's already there. I So the data folder is here and example.txt. Okay, so now, yeah, the content is hello world. So now let's start with the file. How do you handle file exceptions? Okay, so here I am telling, I'm calling a file inside data missing.txt. So this file is not there actually. So what happens if this file is not there? So yes, an exception is thrown. Since I have an exception, so now what kind of exception I'm throwing? File not found error, and I'm catching it here, and I'm printing the error. Okay, so this is how do you handle file not found error. Okay, this would, so yes, this is exception is getting printed, and it is stating no such file or directory, which is true. Missing.txt, we don't have any such file here. We have only example.txt. Okay, so now let's run. So what is this? What happens in this case? How do you handle? Yeah, I'm already handling. I'm throwing an exception. So just a piece of improvement is, yes, in if the file is not there, you can sometimes also mention like this. It is not found. Okay. So I'm trying to, because I'm trying to create in a read mode, because in read mode file must be there. So for some, and I'm printing the same thing here. File is missing. Along with this error message, in some cases you can also just start creating that file and put default content. So this is like a very graceful exit, or it's like adding ice on the cake, like just a file is missing, so it would be nice. That's all. Okay, so now just running this. Okay, okay, so now what happens? Okay, it is not there, which is good, and it is creating a default file is created, and the content inside that missing.txt is default content. So now let's see that too. Okay, so let's refresh once. Yeah, I have that missing.txt now. So it has default content. Okay, so this is the file I just created, just like in the very first cell execution. I checked, okay, this file is there. Now what happens if the file is missing? I'm just creating a file with that and writing default content inside it. Okay, so this is about, yeah, creating a file, and then how do you handle if that file is missing, and then yep, what additional thing you can do if file is missing? You can just create a new one with the default content. So how do you make use of check file existence? See, here I'm calling this function save file read file. So what are the typical things you need to do before reading the data? Yes, first thing is the file should be there, and second thing, the parent directory should also be there. Okay, so let's look into that. Yeah, maybe not, I mean, yeah, of course, parent directory, but that we don't need to explicitly check the parent directory, but yeah, we can just give the path. So data example.txt. Okay, this is safe. Let's see what is the safe way to read the file. So what conditions I am putting. Yes, so I have this parameter. So to this parameter, I have this my file path, current file path, which is data hyphen, I mean data forward slash example.txt. So for this file, first I'm checking yes, if the file path exists, data slash, if that path exists, then you can say yo, okay, file does not exist. If this is a file, okay, it is not a file. So these are the basic two things you will write before reading any file. So what are the two basic things? If the file path exists, it means whether this for data underscore example.txt is exist, and also I am cross checking whether it is a file or not, just in case. Okay, so path is file, so data slash example.txt path is there. If it is there, even though there may sometimes there might be different corruption might happen, so just we need to check, is that a file? Yes, it is a file. So if these both cases are true only, then it will come and then open the file and read the file. Okay, so this is more safe. Here I'm writing exception block just in case if read got failed. I'm throwing an error telling error reading file. Okay, so now let's print, let's see what's happening here. Okay, so first I call this function with example.txt. So example.txt is already there, so the content inside it is hello world. Okay, it says okay, path. So here path means yeah, here you will be getting data slash example.txt. Okay, so it is there, so it will skip this, and it is a file. Yes, this it will skip this, and it will go ahead and it is reading the file. Yes, and finally, yep, we are printing that content. Okay, so this is what you're doing, file content hello world. So I am also again calling this function with a non-existing file. Okay, so this time I am calling data slash non-existent. This file is not there inside the data folder. So what happens in this case, it comes here. Okay, path exists. Which error it will throw, which error it will print, this or this. So it will print this because the path itself does not exist. Okay, yes, so data exists, error data it does not exist. Okay, so you are getting this error because that path itself is not there. Okay, here this is just checking whether if it is exists, whether it is a file or not, we are just checking that here, but here we are just checking the path, file is there or not. Okay, so file is not there, simply it returns here return none. So it will not even open start reading the file also. Okay, it will not even hit this block, it will just return from here. Okay, so that's why, yeah, that's what it's happening for if a file is not there. Okay, and yeah, so this is what you can do, the safe operations before opening a file. Let us look into one more example of safe way of reading a file. So this is one mechanism. So here I have written few checks as error conditions and few checks as exceptions. But here one more way of handling, more robust way of reading the file is I'm adding lot of exceptions. So let's see that style also. So here I'm telling if file is not there, give me this error. If it is a directory, give me this error. If permission errors, give me this error. If any if I can't able to read because of some encoding standards, give me this error. And if not all, give me this exception. So let's run this function with few examples. So there are three examples here. So let's run these three. So first is a valid file because example.txt is already there. And second is instead of file, I'm sending a directory. Yeah. So here, yeah, sometimes it is bit tricky. Out of these two errors, you can hit anything. But for now, I'm getting permission error. It means the file is already open. So that's why I'm not able to get any permission. So that's the point. You are getting here permission error. So next you are getting non-existing. What happens here? This file is not there. So file not found. Okay. So this is also one more robust way of handling a file. Robust way means telling exactly what is error. If you are providing more exceptions, this is also one more safe way. Here you are putting a lot of checks, and then you are also throwing exception. Yeah, this is one way. If the file is missing, I will add a default file. So this is just directly throw one exception, file not found. This is just a single exception here. Okay. So I'm just introducing to different how to handle different exceptions during the file handling. Okay. Then let's see one last example for this Python file operations. Yeah. one more. So cleanup, yeah, we already checked during file operations. Yes, you are opening the file, you are reading and printing the content. If file is not there, I am catching this file not found exception. So whether file is there or not there, you will be running this final block. So what is this final block? It is checking if file and file is closed. You are checking this file is closed finally. This is for graceful exit. Okay. So let's test this function here. So I'm just running this here. Okay. So here you are telling, okay, first test case what it is, data example.txt. Yes, so it comes here. Okay, this file is there, content read how many characters, so that's what I'm saying, it read 13 characters. And since it is a final block is there, it will run this block. Okay, its file is there and if it is not closed, I will close it. Finally closed, this print message you are seeing. Good. So what is the second test case? Second case is, okay, missing file. It means there is no nope.txt. The such file is not there. So what happens here? It comes here. Okay, while opening the file, it throws an exception. So once exception is thrown, it comes here. It says file not found, and again it comes here. It even executes this final block. Since file is not there, it will not print this. Yep. So that's what you're seeing here. Missing the file, nothing to open, file not found. Okay. So this is one example of using final block during exception or during handling file operations. Okay. We already seen this, but it's a kind of repetition only. So one last thing is how to validate file operations. So one more thing here I'm telling. See, in case you are telling safe way to, we have seen ways to robust read and safe read. So we will do what, how to write data safely into the file. So this is the file, this is the content, and the function I'm calling, I have created my own function, safe write file. So what is happening here? So it comes here, safe writing file. So I'm creating a path object here. So before writing, I'm checking if parent directory exists or not. Okay. So how do you check? This is the path. If not, parent exists, which is true, then you don't need to do anything. If parent does not exist, then come and create a directory. So this is more safe way. Okay. So for example, here I don't have output folder. So if you can see my, I don't, in the inside the data, there is no output folder. So now what it will do? Okay, there is no output folder. It does not exist. Go ahead and create the output. So it's always safe. If you are using more directory inside a directory, create all the parent directories before the file. Okay. So now, but before writing, do you have the permissions to write inside the directory? You can check that using this OS path library. So it's like OS access path, yeah, as W. So W means write permission is there or not. If write permission is only there, then go ahead. If it is not there, yes, then don't write. You don't have permission, return false, or okay. I'm printing this error. So finally, yes, parent directory is there and I have permission to write. If both is passing, then you come here, you open the file, you just write it. If there is an exception while writing the file, catch the exception, print it, and return the false. Okay. So let's test this function too. So I'm entering yes. For the first test case, it says yes, creating a directory because it's not the data output. Successfully return the value results.txt, and yes, what is our content test result. So let's check that. So let's go to the home directory. So now there will be a folder called output. Yes. Inside this output, I'm creating a file called results.txt. Yes, inside that I'm having this test results. So I'm also telling to create one more file, test.txt, but this time under the data folder. And yes, this is the path. Yes, the same function works here and same thing happens here. Okay. So now let's see whether this test.txt is created. Okay, I'm coming here inside data. This is test.txt. Yep, another test. Okay. So this is the content, another test. So this is how you safely write. You check the parent directory, you check the permissions, and these are all above all the mechanisms how to safely read. Okay. And yes, so next is about one last, usually cleanup, validating file operations. Yeah, that's it actually. So the key takeaways are use specific exceptions, and you always check before you act, log the errors, graceful exit. So and in AI and ML, you should do a lot of things on files also. So please keep practicing this file operations and how to handle file errors and all other type of JSON file, CSV file, everything. Okay. So on that note, we will end this module. Thank you. Bye bye.